So in this video, we're going to be talking about Newton's second law of motion. So remember in our former class, we talked about impulse and momentum, and we said that impulse is equals to change in momentum. So if you are talking about change in momentum, you're talking about impulse. So from this, we derive the Newton's second law. Therefore, Newton's second law states that the rate of change of momentum of an object in motion is directly proportional to the force applied, which is Ft here is equals to change in momentum. What you have to do is just to make F the subset of formula. So making F the subset of formula, we now derive the Newton's second law of motion. As you can see, here is the Newton's second law of motion. Why F is equals to mv over t when the initial velocity is equals to 0. Because some questions will look like this. You are going to use these two formula in solving them. Let's practice some questions. A particle exerted a force of 350 Newton and attained a change in velocity of 750 meters per second in 25 seconds. Calculate the mass of the particle. In calculating Newton's second law of motion, what you only need there is just use the formula and make what you are asked the subset of formula. That is the only problem in Newton's second law of motion. I think Newton's second law and third law is easy compared to the Newton's first law of motion. So solution. A particle exerted a force of 350 Newton. Force is equals to 350 Newton and attained a change in velocity of 750 meters per second in what? In 25 seconds. In 25 seconds. So which formula are we going to use? We're going to use F equals to change in momentum mass final velocity minus initial velocity over time. Remember that this final velocity minus initial velocity is equals to the change in velocity. So we are going to just write it straight, change in velocity. We are not going to write v minus u because we are not giving the final initial velocity. We were giving the change in velocity straight. So force is 350 Newton. What you have to do here is to make m the source of formula because this is what we are asked to find. M bracket change in velocity is equals to 750 meters per second all over time. Time is 25 seconds. So making m the subset of formula, we have m is equals to 350 times 25 divided by 750, which is now equals to 11.67 kilogram. Nothing should confuse you here. Is 25 multiplied by 350 and divided by 750. So let's practice more questions. A car of mass 500 kg moves the velocity of 50 meters per second in 400 seconds. Calculate the force of the particle. So feel free to pause this video and try doing this one yourself. But let me give you a hint of solving this one. When solving this one, we need this formula. F is equals to mv over t. And we're asked to calculate the force of the particle. Just substitute for what you are given to in the equation and solve for the force. So let's practice it. So we're asked to find the force when we have the formula already and we were given the mass. The mass is 500 kg. The velocity is 50 meters per second. Velocity. What of the change in velocity? Why did I just call the same velocity? Because this is the formula. When initial velocity is equals to 0, we are going to use this formula. But if we are giving change in velocity and you're not giving the final and initial velocity, just go straight and use the change in velocity. But if you're giving the final and initial velocity, just solve for the change in velocity and make it subset of formula and solve for what you are looking for. But here, no, the initial velocity is equals to 0. That is why we have this formula mv over t. Sorry, we are asked to calculate the force, which is the time is 400 seconds. So let's solve for the force. 500 as the mass times the velocity 50 all over 400 just use your calculator and press this. You're going to have this cancel this cancel this. So you're going to have 62.5 Newton. So this is all I have for you for Newton's second law of motion. So thank you for watching this video, and don't forget to hit the subscribe button for more videos like this on Sagashaw's Learners. And we are going to be talking about the third law of Newton's in our next video.